this assessment, we're asked to give the oxidizing agent that will result in this secondary alcohol being converted to the ketone shown. It turns out there are a lot of different answers here, so we'll just list them all. We could use, because it's a secondary alcohol going to a ketone, we're not concerned about overoxidation to a carboxylic acid. And so for that reason, we could use one like chromic acid. We could also use PCC, which is another chromium-derived oxidizing agent. Now, both of these have chromium, which is somewhat toxic, so if we wanted to avoid using toxic chromium, and that's probably a good idea, we could also do the Swern oxidation here. Additionally, we could use what's called the Corey-Chem oxidation, as well the Des-Martin oxidation. So some of these where we're just giving the names, you can look up what reagents go with them. But I give all 5 of these just to show that within the field of sort of alcohol oxidation chemistry, there are tons of different ways to do these reactions. And why do we need so many different ways? Well, it's not really perfectly illustrated here, but it has to do with when we're dealing with molecules that have other functionality. So maybe we have a molecule with some other complicated functionality in there that isn't tolerant of harsh oxidation like chromic acid. And so in that case, we might be tending towards one of these others. But for this assessment, any of these 5 oxidizing conditions or oxidation reactions would result in formation of the secondary ketone.